Okay.
So it's my pleasure today to introduce the VIMAL group to give our talk, our AI talk for ISI. And the talk will be led by Wael Abd-Almageed, Lida Dimitropoulou, Leonidas Spinoulas, and Mohamed Hussein. All of them are at ISI. So Wael is a research associate professor in the Department of Electrical and Computer Engineering and the research director for at the Information Institute. He's the founding director of VIMAL. He got his BS in engineering back in 1994, MS in computer engineering, both from Mansoura University in Egypt. He also earned a graduate software engineering diploma in 1997 from the Information Technology Institute in Egypt. And he obtained his PhD with distinction from the University of New Mexico in 2003. Excuse me. So Dr. Abd-Almageed is a research scientist with the University of Maryland at College Park before joining ISI, where he's led various efforts with NSF, DARPA, and IRPA programs. His research interests include representation learning, debiasing and fair representations, multimedia forensic, and visual misinformation identification, such as deepfake and image manipulation detection, and face recognition and biometric anti-spoofing. So far, he's still leading several multi-institution research efforts, including DARPA, Medifor, GARD, and LWLL. So he'll be giving the beginning and the end of this talk, and he'll be also working with his team. First member is Dr. Leonidas who's been a computer scientist at ISI since 2017. And he's been one of the main contributors for the IRPA's Odin's project, and he's currently a co-PI for the Breyer program. He got his diploma degree in electrical and computer engineering from the National Technical University of Athens in Greece in 2010. After he got his degree, he joined Northwestern University and the Image and Video Processing Laboratory under the supervision of Professor Angelos Katsagelos. He got his MS. Excuse me?
Hard names, I said.
Okay. He received his master's degree in electrical engineering and computer science in 2012 and his PhD degree from the same department in August 2016. Dr. Mohamed Hussein will be our next speaker. Is a computer scientist and research lead at ISI. He obtained his PhD degree in computer science from the University of Maryland at College Park. And then he spent close to 2 years as an adjunct member research staff at Mitsubishi Electric Research Labs in Cambridge, Massachusetts, before moving to Alexandria University in Egypt as a faculty member. Prior to joining ISI in 2017, he spent 3 years at Egyptian University of Science and Technology in Egypt. And during his time as a faculty member there, he was the PI co-PI on multiple industry and government funded research projects on sign language recognition and crowd scene analysis. And he's currently a co-PI for ISI projects under IRPA Odin's and the Breyer programs. And our last speaker for the day will be Lida Dimitropoulou, who is a project manager at ISI. In this position, she oversees the planning, coordination, and execution of government-funded research projects and support the writing of new proposals, the submission of IRB protocols, and the regular communication with the sub-awardees. Before joining ISI, she worked as a project manager and research administrator of national, international, and European Commission projects at the Intelligent Robotics and Automation Laboratory at the National Technical University of Athens and the School of Environmental Engineering of the Technical University of Crete, where she also held a research position in environmental, multi-level, and participatory governance. With her combined experience in academic research and project management, she has contributed to the management of many ISI projects, including the one that were mentioned previously. So before I give the floor to Wael, just a reminder, if you're a panelist and you have questions during the talk, this is meant to be very interactive. So please raise your hand or use the chat. If you're an attendee, please use the Q&A and we'll get to the questions during the talk. Wael?
Deborah, thank you so much for the kind introduction for our team. And I want to thank Pedro for encouraging us to do this. I'm very grateful that he asked us to do this talk. Meanwhile, if somebody thinks that this is a shameless promotion of the group, you can also blame Pedro. He's my boss and I cannot say no. So either way, it's Pedro's fault. We will talk today about the new lab that we started back in January, a couple of months ago, and we called it Visual Intelligence and Multimedia Analytics Lab, VIMAL. And VIMAL actually in Hindi means pure, and it basically reflects our pure commitment to inspiring and empowering our students to be better researchers, better human beings, and do great things for humanity. Meanwhile, VIMAL also, if you want to take the joke, VIMAL also is a type of bath soap, and also a disinfectant that can be used to treat COVID if you want. So enough with the stand-up comedy. Let's talk about the team. These are basically the 4 crazy people who decided to start VIMAL last year, or about a year and a half ago or something. We start discussing this idea of creating a new lab with a specific mission and vision. Mohamed is our machine learning guru. He is one of the best computer scientists and machine learning scientists I have ever worked with in my career, and he leads our efforts in machine learning and basic science. Leo is our one-man show. He's good in everything, from all the way from machine learning to image processing to software engineering to electronics. Lida is our boss. She makes sure that we don't screw up and we deliver things to government, whether it is systems or software or financials, to the government on time, so that we can continue growing. And then the final person who basically does nothing and takes all the credit from everybody else, that's me. So these are the main 4 people who decided to start this idea about a year and a half ago or something like this. This is the rest of our staff. Waigu is a computer scientist in the Boston office. Joe is our software engineer in Medina del Rey. Sean is our lead software engineer, and he's in Atlanta. Mora is the most important person in the whole group. And then Amy is our newcomer to our group, as in her new role as a project manager. And the most important part of all of this is a little bit slow. The most important part of all of this is the main reason why we started this, is our students. The top row is our current PhD students. The bottom row is our current master's students. We have a bunch of amazing students. This is why we wanted to start this with a new vision to empower and inspire them. Meanwhile, we care a lot about everybody who joins our team. That being said, don't leave, because if you leave, we actually hold grudges. So if somebody wants to decide to join our team, think carefully about leaving. We don't like it. That being said, these are some people who made significant contributions to the team before they actually left and started their own careers elsewhere. Rex, Jacopo, Hingama, Ayush, and Faye made significant contributions before they started somewhere else. So I want to thank, they are not here today, but I really want to thank them. I hope they will get the message one day or somehow. Our mission is, as I mentioned, simply, we want to empower students. The most important product, or the #1 product of an academic institution, is students. It's not research funding, and at least this is my perspective, or our perspective. It's not research funding, and it's not papers, and it's not software. It's students, and we want to empower students to literally create great things to make the world a better place one day at a time. And that's our mission. This is what what guides us literally every single day when we start working every morning, right? For those people who actually went to the lab downstairs on the 6th floor, this is hanging next to the whiteboard in the student area. And for those of you who don't know, this is a scene from the finale of Big Bang Theory, where Sheldon Cooper actually was giving his Nobel Prize speech. And I keep telling our students every day, if you can see it, you can be it. Sheldon Cooper, from the first episode in Big Bang Theory, and for the next 10 years, was talking about winning a Nobel Prize. And I really genuinely believe that we have great students who actually can be Nobel and Turing Award winners if they just want to be, if they can just see it. This is actually hanging on the wall in the lab downstairs on the 6th floor in the marina. Our vision basically details our mission. We want to be, and we aspire to be, one of the best artificial intelligence research groups in the world. And we genuinely think that we can, through our students and staff and support staff. We really think we can. And we can do this by emphasizing innovative algorithms and innovative machine learning algorithms, emphasizing solid engineering. We don't look down at engineering. We really think that anybody who's doing artificial intelligence or biometrics or computer science must be able to do great engineering as well, right? And again, we do both algorithms and engineering to improve the quality of life. This is how we see it. This is reflected in some more details. One of our main motivations is that we live in an extremely fast-paced artificial intelligence community these days. Students are working in artificial intelligence is emotionally stressful, but we want to empower and inspire students to dream big regardless of these stresses. And we want to help them do that. Again, we want to create solid engineering prototypes. We already have transitioned 3 of our systems to different transition partners with the federal government and other agencies. And that's basically by creating, making sure that we ensure the security of people and ensuring the authenticity and trustworthiness of various kinds of information. We gained some recognition lately. The lab was on actually CNN a few weeks ago because of our work on deep fakes. The lab was also mentioned in Scientific American, also because of our work on deep fakes. And these are just a couple of examples. I represented the lab a couple of weeks ago in a European Union webinar. The European Commission is the executive branch of the European Union. We were talking about fake visual evidence. And in October, the lab was actually invited to the Biometrics Institute and the Biometrics Institute Congress in London to present our work in biometrics for the last 6 years. We were successful attracting some influential speakers. We invited Daniel Citron as an inaugural speaker for the lab in January. Daniel is a world-renowned law professor with UVA, and she's an author, and she's a legislator and a MacArthur genius. In 2 weeks, we have Ahmed El-Gamal from Rutgers. He's on the right side picture here. I like to call him the Beethoven of AI. He's an AI researcher who's most recently is known for using AI to complete Beethoven's incomplete 10th symphony. And many people don't even know that Beethoven had an incomplete 10th symphony. So we have been lucky having some really nice events. I don't know why my slides, okay, my slides are finally moving. So these are basically the 3 main research themes of the lab now: biometrics, misinformation, technically speaking, identifying or combating misinformation, and AI in medicine. We don't have time to brush on all of them today, but we will talk about biometrics and misinformation. And with that, I will leave it to Leo.
Yeah. Hi, everyone. I'll share my screen in a second. It's full screen, correct? Yeah. So hi everyone, I'm Leonidas Spinoulas. Thanks for the introduction earlier. So I'm going to talk about pushing the boundaries of biometrics research. We had a couple of projects in the last few years in our lab about biometrics, and we're very happy we are continuing this effort. So one project that started 4 to 5 years ago, it's about the biometric authentication with timeless learning project. It was funded by our IARPA, and the goal was to develop biometric presentation attack detection technologies to help the government better detect when someone is attempting to hide their identity by spoofing biometric access control or authentication systems. So now we are in the last phase of the project. It's actually one of the few projects at ISI that have moved past the 3 phases that are usually common to IARPA projects. And we are now in the transition phase, meaning that basically interested government partners are interested in our technology, and they have asked us to develop additional replicas of our systems for them. And the new project, which is a multi-million, multi-year project, is a GRAIL, the Generative Range and Altitude Identity Learning. It's funded by the IARPA Breyer program. It started in November 2021. So we're still in phase 1. And the goal is to provide the US intelligence community with the ability to perform accurate and reliable biometric identity intelligence with a wide range of sensor platforms. I'm going to talk about it later. It's mostly from large distances and from high angles, if you wish, from drones and surveillance cameras. So this is just 2 teaser pictures. I'm going to talk about them later, but just to give you an idea about what the projects are all about. So going to the first project, the biometric authentication with timeless learner. So in a general biometric system, you have different components. So you have the sensor that you capture the biometric data, then you have the feature extraction. And after that, you usually have a matcher that tries to match those features to a database. Then you make a decision about whether this sample is fake or not, or maybe who the person is, who the person you're capturing is. And there's multiple ways you can infiltrate such a system. Different parts of this pipeline, if you will. Some of you might be familiar with what Wael mentioned about deepfakes, for example. That would be a digital attack. So you're trying to create a fake video that would try to fake the identity of a person or change the appearance of a person. But in this program, what we're really interested in is the presentation attack. So presentation attacks is when you're actually trying to make an actual a face look different, a finger look different, or an iris look different. So when it would be captured by the sensor would be fooled. Then it would think that this is an actual person. And there's 2 main challenges in this domain. So one of them is the inadequate sensing. So usually government entities right now, they have just color cameras, what you would go through a security checkpoint at the airport. And here there's just an example. This is actually a collaborator of ours from the Idiap Research Institute. And this is a 3D printed mask, high resolution 3D printed mask of him. Maybe this is not the best example here because the colors look different, but a sensor of just color data could be fooled believing that this is actually this person. And on the other side, we also have a known attack. So if it's fine if an algorithm has been trained on a series of attacks that we know how they look like and how they appear. But what if someone comes up with a new attack? This is a silicon mask of that same person. Can that be detected by the algorithm, by the sensor we're trying to build? So this was a very sensor-based program as well as algorithmic as well. But we based our philosophy was to use basically multispectral data and try to capture information, additional information about the materials being used or about the way people are trying to create presentation attacks. And we built them a system, a common system for 3 biometric modalities for face, finger, and iris. And the main components or the main objectives of the system were to be multispectral. So we use multispectral data, different illumination sources. Everything was synchronous. So we were synchronizing the illumination with different types of cameras to capture diverse data. The illumination was active. So we're assigning LEDs to people's faces or fingers, etc. And also the design was very generic, and it can be actually used in other applications as well, as we will show afterwards. And we use basically the same exact design for all three biometric modalities, with minor modifications, maybe different LEDs, different cameras, based on the particulars of each biometric modality. And one final objective, but was very important as well, is to be legacy compatible, meaning that the data captured by those sensors should be able to be matched with data that are actually existing in current databases. Let's say the FBI has a big database of people. You should be able to match that data to existing databases. Otherwise, it would be worthless for the government. So one big component of building this system was to create custom illumination modules. So we created electronic components that we were able to modify for each sensor and use different LEDs with different illuminations, but also offered us the opportunity to have a common design. Obviously, I'm not going to go into all the details, but here it just shows you the different configuration in each sensor and the different wavelengths and that were used. And we built, as I said, 3 systems. So the iris biometric system used NIR thermal and depth data, and the NIR camera. One of the NIR cameras is also what people are using now at the airports. I don't know if you're familiar with the CLEAR program, that you can actually show your iris and you can go through security this way. And it was using 4 different wavelengths. Then the finger biometrics, they were using 2 cameras capturing visible NIR, shortwave infrared, back illumination, and laser data, and 11 different wavelengths. So these 2 systems, the iris and the finger, we progressed through phase 2. And then for phase 3, we focused mainly on face data because the government asked us to focus mostly on that system. So that has been one of the most successful systems we have built in terms of the performance and accuracy. And the initial system had 6 cameras, RGB, a stereo pair of NIR cameras, shortwave infrared, thermal, and depth data with 10 different wavelengths. But we also built a new system, a miniaturized, if you wish, version of our initial system. That's the system on the right that only uses 2 cameras. So this, or rather 3 cameras, but the one is just it's used as guidance. So the reason we built that system is because we found out through our algorithms that basically the RGB and SWIR data were the most important for performing this representation attack detection. And we also made it using 3D printed components, so it's much lighter, much easier to construct, and much more easier to replicate as well in terms of the alignment of all the cameras. And so the face station was very successful in the sense that the government asked us to, they extended our funding for 6 more months to build the miniaturized version. And they now in the transition phase, they have asked us to build 2 replicas of the system, of the old system, 4 replicas of the new system, as well as performing a auxiliary task, which is only for US citizens, which I'm not, so I cannot go into the details, and I don't know the details. But they have asked us to also design 10 replicas of that system. And as you can realize, we got much more money and the funding was extended in order to perform this transition task as well. And now in terms of the algorithms, here, this is not the only algorithm we produce, of course, but all the algorithms we created were based on deep learning. This just gives an overview of an algorithm that will work on all 3 modalities. So it was a fully convolutional architecture that was capable of taking an image, give you a PAD score map, 1 meaning it's fake, 0 meaning it's real. So basically it gives you a map of which areas the algorithm thinks are fake or real. And then based on that, it gives a final score between 0 and 1, a continuous value between 0 and 1, which is basically a probability if something is fake. And we achieved very high accuracy. For the face, it was 100%, and that's why it played a big role in continuing our funding in phase 3 into the transition. And for finger and iris, we were at 99 and 97% respectively. Sorry, and what I forgot to mention, that this evaluation was performed by a third party. So IARPA had asked the Applied Physics Laboratory of Johns Hopkins to perform this independent evaluation. So we're not involved in that evaluation. It was basically, we gave our systems and they performed the evaluation for us. And another important contribution to the research community was the face and the finger data set that we made publicly available. And you can use our website to download the datasets if needed. And they're the first datasets that have so diverse information and so many different channels at different wavelengths. And so far, we gained a lot of interest in those data sets. Last but not least, we took two different additional research directions that I don't have time to talk about in detail, but one of them was timeless learning, which was also in the title of our project. So that has to do with unknown attacks. So we designed an algorithm that, based on the feature space of an algorithm, it tries to create a new algorithm of features outside this feature space. This is the bona fide PA space. By creating features outside this feature space and retraining the algorithm, we were capable of basically improving the detection rates for unknown attacks as time goes by. So basically, the algorithm would retrain itself every so many samples, and we showed that basically improve the performance over time and be able to detect new attacks. And the second research direction, which was not originally in the project, is explainability through natural language. So we also built this algorithms that were capable of not only giving you a score if it's fake or real, but also gives you a description of what the algorithm is looking at. Basically, it's a description of a mask that someone is wearing or a makeup that someone might be wearing. And this is written as text. This model has not been perfect, but it has worked reasonably well. And IARPA was very interested in that new approach that we took as well. And in particular, the IARPA program manager said that these research directions, he called them as trailblazing. And as I said, they were not included in the original proposal. And down
Leo,
yes.
Leo, I'm really sorry. I don't mean to offend you. Let's skip this for the interest of time and go to Mohamed.
Okay. Yes. Sorry, I took a little bit more time. Sorry.
No, that's fine.
Okay. Can you see my screen now? I think you can see now my slides. Good morning, everyone, and good afternoon, depending on where you are. My name is Mohamed Hussein. First, thanks to Bora for the first introduction, and thanks to for the second introduction, which was quite flattering, and I hope I deserve just part of it. I will be presenting today our group's effort under combating visual misinformation. Specifically here, just a second. Yeah, specifically here, I'll be talking about three different topics that are related to misinformation: image repurposing detection, image manipulation detection, and deepfake detection. The first is image repurposing detection. So what's image repurposing? If you look at this image on the right and text on the left, when these go together in a social media post, they give the impression that this image is taken at the southern border of the United States of America. However, if you trace the origin of the image, you will find that this image actually is for Pakistani protesters at the Pakistani border, not the southern border of the United States. So the image was taken out of context, was taken out of location, and out of time, and put in a totally different location, time, and context to give a false impression and deceive people. And that's what we call image repurposing. To formulate the problem of image repurposing detection, we look at the multimedia, the image and text and anything else as one package. So specifically to begin with, we will define the package as an intact image and the text description for that image. Then the problem is given a query package, that query whose integrity is under question. We want to verify the integrity of that query package using a reference dataset. The reference dataset is assumed to be of packages with known integrity. So how to do this and how to evaluate this? We actually, when this started in our group in 2017, there was no dataset out there to work on this problem. So that's why our group introduced the first dataset for this problem, which is called the MAME, Multimedia Information Manipulation Dataset. It contains around 250,000 packages. Each package is a text and image. And that was a contribution for the research community. The MAME dataset was great as a starter, but it was not perfect. It had a number of limitations. First of all, the packages were limited to only images and text. Also, the manipulations were created by swapping captions of different images, and that sometimes resulted in unreasonably simplistic manipulations that cannot fool people. Another limitation of MAME dataset was that the reference dataset is not guaranteed to include relevant information for the query packages, which means sometimes you make just an arbitrary decision because the reference dataset doesn't include relevant information. So to fix that, our group introduced another dataset. But before that, first, let's just adjust the definition of image repurposing detection, the formulation, by expanding the package definition to include not only image and text, but also to include geolocation and other related information. The next dataset is called multimodal entity image repurposing, MIR. And this has, in addition to image and text, it has also the GPS information. It has the geolocation of the package. It has more realistic manipulation. That's probably the most important part. So the manipulation this time are not created by just swapping whole descriptions, but by swapping named entities. So first named entities are detected, which refer to either person, location, or an organization. And these are swapped between descriptions and along with any other metadata that's relevant to the named entity. They're also swapped to make more plausible manipulations and more challenging manipulations as well. The end result was a data set of over 80,000 reference packages and close to 60,000 query packages created, as I said, by using this manipulation technique. And I have to say also the reference data set included relevant information to the query packages by design. That's what I have to say about image repurpose. Of course, there are methods that go with these data sets, but I only mentioned the data sets because that's, I think, for the time constraint. Next, I will talk about image manipulation detection. So there are different types of image manipulation. So, and I will talk about specific types that our group worked on. The first is the copy move. So copy move happens when an object in an image is replicated one or more times. So if you look here at the image on the right-hand side, you'll see three different faces. If you look at the left-hand side, you will find that one of the faces was actually replicated 2 times to create a manipulated image. And that's an instance of a copy move manipulation. So this is, and what you see in the middle is the result of one of the methods developed in our group. And the method does not only recognize that there is a copy move forgery, but also localizes the copy move and localizes also and distinguishes between the source of the copy and the targets of the copy. As you can see, the green is the source and the reds are the targets of the copy. Then our group developed a more generalized method that detects, a broader range of manipulations that included copy move along with splicing, removal of parts of the image, and general image enhancement. And again, the method both detects the forgery and localizes it in the image. So basically, if you look here, the left-hand side column, these are the original images, intact images. The middle column includes the manipulated images, and the right-hand side column includes the output of the algorithm, which gives per pixel determination if this pixel is manipulated or not. And it works actually quite well. Last but not least, I will talk about deepfakes. So our group also has a public service that a web-based service that people can use to upload videos, like the one I will run right now. Yeah, this is the video for the Ukrainian president telling the Ukrainian people to surrender, asking the Ukrainian people to surrender to Russia. That was very recent. And as you can see, the video is very compelling, very realistic, but actually this is generated using deepfake techniques. And the method that developed in our group can give per frame determination if the frame is manipulated or not. And then by aggregating these scores over the entire video, you can tell if the entire video is deepfake or not. I know that the voice here is not relevant because it's not in English anyway. Relevant for this audience. So I will just stop this video and that's actually the end of my part. So I will stop sharing my screen.
Thanks, Mohamed. Lida, you're next.
Okay, let me share my screen. Can you see full screen?
Lida, I think you're sharing an older version. Let me share mine and you can tell me to go next.
No, I just added something. I mean, removed something. Okay, so I would like to thank both Deborah and Wael for the introduction. I feel so lucky to be part of ISI and especially of this group of VIMAL. And I'm going to give you a brief overview of our project, our funding sources, and how we have organized project management within VIMAL. In the field, we are doing research in 4 main fields. In the field of biometrics, we have 2 projects sponsored by IARPA. We have Odin and Briar, and with these projects, we develop systems and algorithms that are resilient to presentation attacks of biometric authentication systems, as well as systems and algorithms for face and whole body authentication at altitude and range using long-range visible imagery under challenging imaging conditions. Then we are doing research in multimedia analytics, and here we have MADI4, SEM4, and INCAS. These projects have been funded by DARPA. And with these projects, we are working on developing deep learning methods to detect medical image manipulations, or, for example, analyze social networks, image and video content to improve campaign awareness and sense making. Then, of course, we enjoy very much working in the field of medicine. So here we have the phase 2 CAH project. With this project, what we intend to do is to use the face as a phenotypic biomarker that can easily be used by physicians to adjust medications for patients of the congenital adrenal hyperplasia. I don't know if I said that correctly, which is a very serious genetic disease. And of course, we are doing research in machine learning. We have GUARD, Fast Search, and LWLL. The first and the last one are DARPA sponsored. Fast Search is sponsored by the National Geospatial Intelligence Agency. And the idea of these projects are to develop algorithms and systems for fast indexing of global reference data and fast and accurate geolocalization, or algorithms that require significantly smaller amounts of labeled training data for computer vision and natural language processing tasks. and robust to adversarial attack deep learning models. So our sponsors, for the last 5 years, we have received over $15 million from all sources. We have enough funding through 2025. And you can see DARPA and IARPA are very much, contribute very much the same. And then we have funding from the National Geospatial Institute and the National Institute of Health. Now, how we manage our research. The goal of our project management system is to support our research and ensure that each project is implemented on time, on budget, and within scope, and with full respect to the limitations of our sponsors and ISI USC. So this is a mess of tasks, as you can imagine, and these tasks need to be addressed at the same time, not just within every project, but across the different projects that VIMAL has. And this also includes projects for which we are not we don't have the primary role. So we have created a system that streamlines the internal technical and administrative processes within VIMAL and facilitates collaboration with the business office, communications, purchasing, the IRB office, Stevens, yeah, and of course the sponsor and the subcontractors, seeking, to meet in a timely and financially sound way the contractual obligations of each project. So I give you some general overview. So we have what we do at VIMAL. We talk a lot with each other. We brainstorm. We start with a dream, let's say, of a kinder, healthier, safer world, and we come up with ideas. And once we select one idea, we can support all the 4 phases of project's life cycle. So for initiation, we can support proposal preparation, partners communication, IRB protocols and protocol submissions, among other things. During the planning phase, we are working on milestones and deliverables. We can support scheduling, data management plans, DUAs, contingency plans, and whatever else comes up during this planning phase. And the most extensive role of our management system is during the execution of a project's life cycle. So here we are using Trello to track tasks, progress, and interdependencies. We use Google Drive to record costs and track purchases, consultants, and labor allocations. Give me a second. We use Overleaf to prepare the deliverables, technical and technical reports. We handle revisions, change requests, sponsor authorizations. We work on budget, equipment budgets, or travel budgets, labor, and organize, plan data collection. And we maintain regular communication with subcontractors and our program manager. So these are a few of the tasks we do during the execution of a project. And then we have the closure phase when we have successfully completed a project, or not so successfully. Usually it is successfully. So we prepare the final technical and financial reports, and we do an internal evaluation to see what we did well, what was wrong, and try to learn from this process when we move on to our a new project. Now, all this would be impossible without having good cooperation, good collaboration with many other offices in ISI, USC, or our sponsors, or our subcontractors. So during the initiation phase, we work closely with the pre-award and the action team. During planning, again, with the pre-award action, and here sometimes if there are human subjects involved in our research proposal, then we work closely with the IRB office, and of course with our subcontractors and the technical leads there, and sometimes the financial people. During the execution phase, of course, we rely on post-award. Always Action is there working with us. Of course, purchasing, accounting. Sometimes we might work with the contracts people, IRB office at USC, Stevens, and our subcontractors. And during the closure of a project, we work closely with a sponsor, with facilities people, to make sure all equipment, everything is in place, and we have a good record of them, and make sure our subcontractors have delivered everything, and everything is in place. So yeah, this is a very broad idea of how we organize management. If you want more questions, you can always email me.
Thanks, Lida. Let me share my screen. I will just share some final thoughts. So these are some final thoughts. And sorry, Deborah, for some reason I can't share audio, so you will have to read the caption in the video that I was referring to. So I really think, or all of us really think, that everything is about culture. And we're trying to instill a culture in the whole lab that we are one family and one team. That doesn't necessarily mean we all share the same ideas. We don't have to agree all the time. Actually, we fight a lot within, in terms of to basically achieve the same goal, which is winning. This is about winning to us as a team, and instead of winning as different individual people. So it's about culture to us, and we want, and part of this culture is again back to what I was saying earlier, empowering students, doing great things, and improving the quality of life of humanity. And all of us have different views about this, but we at least share the same overall goal. We are diverse, as you have seen from the pictures of the team I shared before. We're diverse, but we work as a family. And I am not totally against the idea of that. Sometimes we actually get mad at each other because we are human beings at the end. But at the end of the day, regardless of our disagreements in meetings or the way we execute efforts, etc., we're perfectly okay going out to dinner or lunch together and have fun and share laughs. Disagreements in the workplace do not necessarily mean that we don't like each other. And as a family, as the VIMAL family, we actually support each other. And there are many instances in the last couple of years where we were actually there for each other. We got each other's back, especially our students. Again, the main purpose of the lab or the vision of the lab is to actually inspire students and empower them to be the best thing they can be, the best version of themselves. I totally believe that our students can actually touch the sky if they want to. And our mission in the lab is to maximize their potential. Maximizing the student potential does not mean we're always quote unquote nice to them, for a lack of a better word. It means that we continue to push them to be the best version of themselves. And I hope the students will agree that that we actually genuinely care about them and we want them to be the best versions of themselves. And we try to do all of this with some sense of morality and ethics. We do this thinking that what kind of applications will be developed using the technology. We never thought about creating deep fakes. We always thought about defending against deep fakes, even though that we can develop generative models that create these deep fakes really well. But we always try to think about the ethical and moral dimensions of any algorithms or software that we develop. Finally, this is a picture, this is a painting of the Diogenes the Cynic. He was basically trying to search for an honest man back in Athens many thousands of years ago. I totally get it that maybe some people will be cynical whether we can achieve this vision or not. And I don't know. I don't have an answer to this question, but I can share this. This is a really famous video from the great late Kobe Bryant. Let me play it. It's just a few seconds.
Like I would watch Magic play, watch Michael play. I would see them do these unbelievable things, and I said, you know, when I get to that level, I don't know, but.
So we really don't know if we can achieve what we aspire for, but let's find out. And thank you.
Thanks, Wael, for sharing your research with us and your new lab. There's one question in the Q&A, which is regarding any opening for MS students in the team in the near future.
There is an alias on the website of the lab. The website of the lab is vimal.isi.edu, and there is an alias where a few of us receive any applications for students. Just send us your resume and we will look into it. I think the alias is vimal-jobs@isi.edu.
All right. Are there any other questions? Reminder, if you're an attendees Q&A, if you're a panelist, raise your hand and you can ask the question live.
So I have a question about the data sets for the kind of the repurpose images detection. That seems extremely hard, and I'm sure you've done something reasonable in these data sets, but I mean, those are like taken kind of out of context. So it's a demonstration that happened in one place at one time and is used in a different place at a different time. I mean, how have you validated that those images are, you know, the data set kind of still kind of fits the normal purposes, which is this kind of this information purpose and really kind of replacing. I mean, it seems extremely hard. I mean,
It's super hard.
Yeah. I mean, have you tested with humans or things like that?
Yeah. Yes, so it's super hard. And as Mohamed mentioned, when we started doing this kind of misinformation identification a few years ago, there was literally 0 data sets in that domain. And one of the fundamental requirements of this work is that the reference data set must be high provenance data set, high integrity, right? And what we did is that we collected this data set. Ikram, who is the main driver of this work, who just finished his PhD and moving on to Amazon, congratulations to him if he's listening, validated this data set, at least manually. And what we did, I think we have 2 main contributions to the field. One is we introduced some data sets that can be used to at least to get research going in that field. And then we also introduced some proof of concept ideas, algorithms that we published in ACM Multimedia 2018 and 2019 that basically show if you have a high provenance data set, you can actually do image repurposing detection relatively well. But again, I agree with you, finding a high provenance data set, at least for the public, is a really difficult task.
I mean, are there existing collections of people have already identified? I mean, for example, the example that you gave, I think it was like some kind of Pakistani immigrants, and they were said that they were in the southern border of the US. So if a human, maybe if you look like Pakistani looks like, or how and most of the immigration that comes from the southern border look like, you may realize that it's out of place. But I mean, are there already collections of existing?
There are government collections. There are government collections. There are no public collections, public domain data sets. So I know for sure there are some government data collections. They actually consider it extremely high provenance that they can use as reference data sets for validating query packages. And again, in terms of the public domain and research domain, there was really nothing. 5 years ago, when we started this, we found 0 data sets. It was extremely difficult to even define what the problem is because the problem didn't even exist. But big part of the challenge when we started years ago is even defining what the problem is, what does image repurposing actually means, coming up with a benchmark and metrics to evaluate these methods.
Thanks.
I may add something for data set. For the data set, it's a research data set. So assuming the reference data has provenance, then the evaluation. So under this assumption, the evaluation is carried out. So it's it might not be 100% accurate, but the evaluation is done assuming that this is the reference. It is considered the reference. So the results can carry out if you have a pure data set.
Okay, thank you.
And just to be clear, we're not claiming by any means that we actually solved the problem. We're literally scratching the surface. And we had a discussion over the AI retreat in Los Angeles a couple of days ago. I really think after years of working in that domain, I really think that if we really are serious about combating misinformation, it has to be, number one, multimodal effort, not just visual or text. It has to be multimodal. And it has to include social network analysis, because information does not propagate in a vacuum. Information propagates usually over social networks in this day and age. So the way information is created and propagated on social networks is what needs to be used to combat misinformation.
Well, thank you to all of our speakers today for a great talk and great presentation of the laboratory. And we'll see everyone back next week for our next AI session.
Thanks, Deborah, and thanks everyone for joining.
Yeah, thank you.
Thanks.